Hi, this is Amin, and in this video, I'm gonna talk about the formal report of our final project for a study at Humber College in the course of wireless telecommunication. So the topic was wireless coverage, experiments using a Blinq LTE fixed wireless access, and we're a group of three. This is Amin with cooperation of Subjit and Pooja, and professor was Mr. Qazi Faisal. It was in the summer 2021. So as the topic was in the LT, we came up in the content of our project with introduction of LT, background of that, eNote B, consumer premises equipment, about CP, about EPC, data acquisition, and that sort of things. And we would like to thank Mr. Qazi Faisal because he gave us the direction how to do the project. Mr. Giovanni Reyes from Blinq Company, who supported us through doing indoor and outdoor tests, and finally Professor Kevin Ramdas, he advised and helped us during the test, and also he's the moderator of the course. So anyway, let's save some words and go for the results. This is the initial plan of that. At first, it is good to say that it's a cooperation project between Blinq Company and the Humber College. So the EPC and both of them were located at the roof of residential building of the Humber College. So there are some spots for tests, either indoor and outdoor, and we can see at different radiuses. For example, 1 kilometer, 2 kilometers, 3, 4. We've done most of them. Let's start with the indoor test. This is the plan of the building. So we've done the tests at different places, and for indoor tests it was valuable to do that. I mean, in front of the window, at the middle of the room, or against the wall, to see the difference of the received signal level and throughput. And we can see here exactly the results of that. We are look different buildings. It is eNote firmware, for example, second floor, room number L235, window, room center, outside. And clearly we can see here the difference between the throughput of that. We've done the test in either a UDP and TCP for both uplink and downlink. So the different results, and also we've captured the RSRP, SINR, CINR for that, and the noise. So we have rich data to compare and contrast the differences when we change the location of the CPE. And after that, we went for the outside tests, and we've seen that the throughput increased in either case. I mean, UDP and TCP, in both of them, the throughput increased, and there should be a reason behind that. We're going to talk about that anyway. So at different spots, at different places, we've done many tests for 1 cc, and also after that we went for 2 cc, I mean carrier aggregations, and we've seen that the results somehow became doubled. I mean, the throughput increased a lot. So it is very good to do that, but the point is that we cannot do the carrier aggregation everywhere, but at the situation, at the locations that we can do the carrier aggregation, so the result will be different, and we have higher throughput, more bandwidth, and something like that. And so let's go for the report. Here, after doing the tests about and processing them in the MATLAB, we've realized that in some of the places parameters were low, but RSRP was high. So at first it is weird. We should think of that thoroughly. But after taking thoroughly the look at all of these graphs and doing the MATLAB processing and thinking of the concept of UDP and TCP and that, we've realized that there could be two reasons behind that. The first thing is that maybe there is a hardware, there's issue in the hardware, maybe a Schottky died, something like that, after the antenna which is receiving. Or maybe there's a problem in the software, there's a bug or error in the firmware which is running, or at the time of updating the firmware. These are the problems behind that, and maybe these are the cause of that things. And another reason is that maybe there is a noise behind that. I'm going to talk about noise. So let's come here to the PowerPoint that I've made and let's see the pictures. Okay, based on the test, we can say generally the output results were better. But is it common? Is it general? Or can we expand that and say yes, every at every test it is that thing? And if it is okay, or if it is yes, why? What is the reason behind that? The first thing is that by taking a look at these CPEs, we can understand that first the indoor CPE is smaller, so the power that the indoor CPE has is lower. And secondly, it's omnidirectional, while the outdoor CPEs are not omnidirectional and they need line of sight. And we've do the antenna alignment to some have the best signal in order to have the best signal. So this is the first reason, and the second reason is the amount of power. Even though both of them are DC power, I mean these two are using PoE and this one is using DC adapter, but we can say that this one is consuming more power, so it has a better performance for that. And also we can see here in the indoor there is a big fluctuation between the highest number and the lowest number in the throughput, while at this side there is a fluctuation, but not as much as we can see in the indoor test. And the reasons, the first thing is that the electromagnetic wave penetration rate. So when we are using an indoor test, so we should think of that and we should bear that in mind. When we use indoor test, the material of the walls, I don't know, either wood, steel, concrete, whatsoever, are important because electromagnetic wave should come inside from the walls, and it is the first important thing. And the second thing is that as I told you, outdoor CP is more powerful than the indoors, so this is another reason. And finally, we should think of that, and maybe it changed our mind because because of the lockdown, we've done the test inside the college in a situation that no one was there. It wasn't crowded, and it has a direct impact on the tests, because when the place is crowded, definitely there are lots of receivers and there are lots of noises, and I mean it has an direct impact on the test. And also when we are out, many users, many radio, TV, service providers, operators are broadcasting, so the noise is different. On the whole, I can say there's a trade-off. We cannot say generally the outdoor test will be better. We cannot say that, but we can expect that. And these are the results of our test. These are the things that we've done for the project. I hope it was good. Thank you. Bye.